Okay, how's everybody doing today? We good? Everyone's back,
Good,
so welcome back,
good, good.
Clara and Brian.
Very good.
Everyone's there. Okay, so join. Okay, so let's see. Um, I got next class and then spring break for a bit, just to FYI. I'm sure you're counting down the days, but let's. Okay. Um, First thing is I updated the syllabus a little bit just for the grading, because I wanted to reduce the number of homework assignments. So let's take a look at what I changed to, and we can just settle our expectations here. Okay, so the only thing I changed was the assessment of learning, which is the breakdown of assignments. So I decided that if for some reason we fall behind this, I can change it again. But based on where we're at now, I think this will work fine. So I had to, for leveling purposes, I just made attendance 15 points. So pretty much everyone's going to get 15 points unless you miss a bunch of classes. So that shouldn't be an issue. I decided to make, so we've already had three homework assignments, which are 7 points each. So I'll make two more, and that'll be 35 points. Okay, so there's only two more coming. Then we're going to have one, because of the structure of the class, one take-home final. So that'll be 20 points. And then I have an idea of kind of two research projects, which we'll do mostly after the break, which will be 15 points each. So that's kind of the breakdown, which I think we're on track for. Two more homeworks in addition to what we have, a final at the end of the semester, which will be take home, and then two research projects, which pretty soon we'll have all the kind of foundations to start those. So I have a good idea of what I want to do for the two research projects. If you have some other data sets or like projects you've already started and want to incorporate that, let me know by the end of the spring break so I can kind of incorporate your ideas. Otherwise, I have a couple assignments that I can kind of, you know, everybody will have a different topic, but it's in the same kind of project. So if you have something that you really want to research, or you started with some other class or something, and you want to incorporate that here, you have to have the data. So that's the first thing. Is if you don't have data, then we can't do the analysis. But let me know if that's something you want to do. So, uh, yeah, okay. Otherwise, um, so kind of a breakdown of what we've done so far. We've done intro to regression. We've done simple regression. We've done multiple regression. We've done correlation and a little bit of heteroscedasticity, although not too much. What I want to do in the last couple, not the last couple, the last big topics, which will probably be the next two homeworks, is I want to do some simple time series and forecasting. And we'll have to do that in a different platform, which is RStudio. It's a free platform. Maybe we'll download it next time before the break so you can start playing with it, but if not, after the break. And then the other thing I want to cover is some introductory like probability models. So these will be models which are pretty useful, that instead of your dependent variable being like a number, it's a kind of a yes no category, or this or that. So you can predict whether this person has bad credit risk or good credit risk, whether this person is above this tax bracket or that bracket. So basically uh, your y variable is a binary variable, and you're developing a model that says, based on these characteristics, the probability of being this is this, and then the other is the other. So hopefully that doesn't sound too complicated, but it's a very useful type of model to use going forward. And those will be kind of the main things. And then the rest will be incorporating those things into the projects, and the final. Um, so again, let me know. So just off the, I mean, you don't have to you have anything prepared here, but were there any other topics you wanted me to explore that I'm not going to cover, um, that you can think of? Yes. Yeah, yeah. But right. So just I know that Noble wanted to do a little forecasting, right? It's, yeah. So okay, yeah. So if not, I have plenty of things that we can do. Yeah, yeah. So I'll just kind of show you simple forecasting. Forecasting gets um, you can take whole classes on forecasting. It gets a lot. It gets very mathy. So I won't dive into that, but I'll just yeah, well, yeah, yeah. Well, we're not going to predict the weather because no one can do that accurately. Yeah, but that's something I think we would get use out of. So just if they were coming into this class, you had certain models or techniques you wanted me to cover, I could probably cover them. If not, I have a good idea, but I think we can learn the things we can learn to best go with. So up to this point, we've done simple regression, multiple regression, learned now a little bit about correlations and kind of model construction. The next things to do will be learn how to gather and collect a data set to do the model with that, learn how to do some simple forecasting, and then learn how to build a model in which you're predicting the probability of something happening or not happening. And I think that'll give us plenty of stuff to do and incorporate into the projects. So uh, I just noticed that I changed the learning things a bit. I put it down to one final or one exam because it's probably better that way to spend more time on the projects. And then two research projects. So I think this looks pretty good. So sound sound doable? Yeah. Okay. And then I think well, you will, yeah. So I think we'll stick to individual projects because it's such a small class, and it'll be difficult for the students remotely, especially different time zones, to coordinate. So we'll stick with individual projects. I might give you the option to do a presentation if you want, but not required. So you can kind of let me know if you think you're better at giving a presentation than writing a paper. I can make that as one of the, yeah, I can modify it that way, but it's up to you. So we'll get to that point, but I might, at least for one of the projects, I might give you the option. But if you know, so I've done that before, and some students actually prefer, yes. Well, I'm gonna define it for you. So yeah, yeah. So I'm gonna give you a clear uh, research question, ways to get your data, what you're gonna do, unless you have something in mind. Yeah. So the one of the projects I like doing is you have to do something where you can get the data. Um, there's I know that stock price data is easy to get, and so we can do a simple forecasting model with stock prices, and we can also do kind of a simple regression where you're doing, if anyone's familiar with like a capital asset pricing model, what kind of if you know what the beta is, we can do something like that. And then I can also help you build a model where you're predicting like if a county or a place is of a certain category, like you know, desirable or not desirable, or healthy versus unhealthy, things like that. So those I know that I can get data for, and I know that I can give you enough direction to build those models. But again, if you had some other things, if you have other data sets that you want me to incorporate, I can try to do that, or I'm happy just to make up the projects for you. But everyone will have a different topic or variable. Okay. So we'll probably get to those after the break, but depending on what we do next week, I might show you some stuff in a different platform, which is RStudio. And I think most of the things we can do in Excel, except for the forecasting. But okay, so that's the change there. Uh, so I know we're a little behind in the. Yeah, we've only done 2 assignments. I've only graded one, so it's hard to know exactly where you are, points wise. But everyone's been coming to class. Almost all students have all the points at this point, so I wouldn't worry too much about that. Just make sure you come back after the break and don't disappear into Cabo or something. Um, yeah, that would hurt your grade. I promise you that. But is anybody going on vacation or during the break? Okay, you're coming back, right? Oh, next. Okay, no problem. Okay, so we'll have a pop quiz. No, I was kidding. No, yeah, yeah. Well, I have like basically, well, I have 2 jobs and kind of a third, so I won't do it. Okay, great. So, uh, again, you only have one assignment graded. I'll get the second homework graded by next time, so you could have, up to 14 points. We'll start building upon, but I wouldn't worry too much about your points at this point uh, because this class is 16 weeks, and because I wanted to see like where everyone was at, I wanted to spend most of the first half kind of getting ready to do the projects, and then we'll kind of. So, okay, all right. Questions on that? Sounds good. Now, what I want to do today is finish just highlighting the homework that's due next week. So I know that somebody, I think Rashid, if you're there, you might have already turned this in. It's
Yeah.
not, yeah, it's not due until next Saturday. So if you want to make some revisions, you're welcome
Oh,
to
I
and
didn't
send them.
realize that. Oh, wow. Okay.
Yeah. So just an FYI, if we go over something today and you want to make a few adjustments, just send me the updated
Okay.
one. But way to be proactive and turn in a week early. That was great.
No problem. Okay.
Okay. So okay. Um, and then assuming we get through this today, I have a little in-class exercise that I'll walk you through, and you, yeah, yeah, we'll do that first. Yeah, we'll do that first. Okay, and then we did. Last class we didn't finish it, right? Yeah, 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 you're right. So we have to fix that first. Oh yeah, he's Rashid submitted the homework, but I think he didn't know he had next week, so I think. Okay, so first let's go back to week 6, which was last week, and then this is the homework assignment that's due next set.
Over here stressing myself out. I didn't realize it was due next Saturday.
Yeah, well yeah, it's better to be earlier than late, right?
Yeah, exactly.
So no problem. Okay, so I believe we went through the first one pretty thoroughly, correct? And then we started doing the second one, and we did most of the analysis. We were on C. So let me see if I can find the one where we left off. We finished B. Oh, okay, we did. We finished reduced. Yes, right. That was okay. Good, because I don't want to do that again. That's, that's right. We went over. We went over time. We did it. Uh, yeah. That sounds right. Okay. Hopefully I saved my progress. Uh, yeah, ever since they started, I don't know if where you save if you save your work to like the OneDrive or the cloud, you'll notice that like if you sign in somewhere else and like it's still signing in and you save something, it might save it to somewhere else. And so I've done that like with my dissertation. It's been like, I'm like, where the fuck, where is it? Yeah. And I had to like search my whole computer. I can always find it, but it's not a good feeling when you're like, where is this? Um, but okay, so we did that part. We did that part. We did that part. Okay, and this is it. So we've got a model from last time, and if you didn't get to this point, it should be in the last video. Yeah, great. Okay. That's the right, yeah. Okay. That's the right answer. Yeah, right. Okay, so we've reduced the model to a point where curb weight, max seating capacity, and a hybrid uh, are left in the model with significance, and they don't have any high correlations, right? That's where, okay. Now, the next step is to define and interpret these variables, right? Okay. So just start what I had before. Now, this model has, yeah, the same number of variables. So the y variable is miles per gallon, uh, miles per gallon highway. So y equals miles per gallon highway, and that's just the miles per gallon the vehicle gets on the highway.
Quick question. Are you recording this?
Yeah, yes, I am.
Okay. All right. Thank you.
But let me just double check. Yeah, we're good. Yeah. Okay, and you'll notice that usually vehicles are listed in miles per gallon highway because they get worse mileage in the city and they want to report the best number. So anytime you go to like the dealership and it says MPG, that's like the best case scenario, right? You'll never, if you ever get better than that, they'll like, good luck. Normally in this, I mean, if you get like 25 miles per gallon on the highway, it's probably like 15 in the city. And if you're stuck in traffic on like the PCH, you get like 5 miles. It really depends on. It's true. Okay, and then X1 we can define as curb weight. And this is the weight of the vehicle. I believe it's in pounds. Is that how curb weight's normally reported? You would think so. Let me just look at the data set. I think it's in pounds. That looks like pounds, right? Yeah. Let's make an assumption that it's in pounds. So curb weight in pounds. This one's pretty easy. This is max seating capacity. Okay, and this is just number of seats. So like if it's 5 seats, it's a five seat car. Okay, and then X3 would be hybrid. And basically, like if this is if one, if the car is a hybrid. Okay, so our variables here are Y is miles per gallon highway, which is miles per gallon on the highway. X1 is curb weight in pounds. X2 is max seating capacity, number of seats, and X3 is hybrid. One if the car is a hybrid, and 0 otherwise. So, why don't we try to interpret these based on what they mean here? Okay. So, curb weight um, is right there, negative. It's pretty small, but it's in pounds. So this is the effect on miles per gallon on curb weight. So basically, you would interpret this as that's the effect on miles per gallon if the curb weight goes up. So you would say something like miles per gallon decreases by 0.01 mpg with each additional pound of curb weight in the car. Okay, miles per gallon decreases
That was
by
close.
yeah, you were close. Yeah, miles per gallon decreases by 0.01 mpg with each additional pound of curb weight in the car. So each pound would, which makes sense, decreases the mpg by 0.01. So not a huge um, coefficient, but that one's very significant. And the curb weight can be pretty variant. So look at some of these things have like they're like 6,000 pounds. So if you get a pretty heavy car, that's going to decrease the fuel economy. Now, max seating capacity is just the number of seats. So it might be somewhat surprising that more seats lead to better fuel economy, but it shouldn't be so surprising because, so why would we get that outcome? So why would a bigger car have better fuel economy? Well, let's say that what's a typical, do you think a typical two-seat uh like Ferrari gets pretty good fuel economy? No, horrible, right? Yeah, so I think it's skewed because if you look at this data set, there's a lot of vehicles in here which are small, small by less seating capacity, which get really poor fuel economy because they're like speedsters. So here's like a
Going into that, but now we could kind of trying to get into like the technicalities of engine. Mind just going off the deep end.
well, there's an engine size variable, but yeah, basically that's true because but a lot of those things are already captured, but this was one of the ones that did it best. So because the seat really reflects it that way, it's going to make sure that, like, let's look at some of these. I don't know. Clips is a fast car, right? But MPG 25 is pretty poor, but that's a four-seater. So let's look at. I bet if I look at all the two-seaters, they get pretty poor fuel economy. Like this one, it's a Nissan Roadster, 25 miles per gallon. Um, this one, no idea what a Mitsubishi Endeavor is, but only 19 miles per gallon. Okay, this one, a Roadster, yeah, so the reason why the fuel economy goes up with seating capacity is because there's a bunch of small cars, which are fast, but get terrible fuel economy. Look at this one is 12 seat. Is that even possible? GMC Savannah. Oh, it's a van. Oh, that's right. Yeah, and here we go. Here's a bunch of small cars. Corvettes, Camaros. It's actually good, surprisingly pretty good. Oh, I see what you're saying. So yeah, we're not controlling for people in the car, are we? Yeah, yeah, yeah. That's
I mean, not for lead dependent, but if you look at F1 racing, they account for driver's weight
hmm.
and adventures like this, and you use all.
Well, hopefully they looked at the correlations before they. Yeah, yeah. It doesn't appear, but it looks like the ones. Well, also the couple hybrids are probably getting really good mileage that also have like 5 seats. This one, this Yukon uh, is a hybrid, but doesn't get very good mileage. Anyways, yeah, right. Yeah. That's yeah, yeah. So, but that variable was very significant, and we did a bunch of analysis, and it seemed like that made a big difference. So, uh, if you didn't have that, you could probably capture that with other variables. But this seemed like the one that did a very good job of predicting MPG and wasn't correlated with the other things. So what this would mean is that um, on average, um, miles per gallon increased by 0. By roughly 0.98 mpg with each additional seat available in the car. Okay, so again, that's what it says, but it takes a second to go look at why that is before you. Okay, and then the biggest, um, magnitude one was hybrid for sure, but there were only a few observations. So this is our first um, binary variable, right? And so the way you want to interpret binary variables is this is the impact compared to the case that's not uh, so we're comparing hybrids to not hybrids. So the variable that's in the model is compared to the case that's not in the model. So this essentially means hybrid cars got um, an extra 9.84 miles per gallon compared to non-hybrid vehicles. Okay, hybrid cars got an extra 9.84 miles per gallon compared to non-hybrid cars. So that's a pretty big difference. Not sure that would hold for all cases, but if you looked at the data set, you should see that result pretty clearly because there's only a number of hybrids. So we've got these guys here, basically this little group. And there was one more. Was that it? Was those? There was one more. Oh yeah, that was it. Okay. So those all get, there's one that gets 48 miles per gallon, the Prius, the Hyundai Sonata gets 40. So they all get, except for this one, pretty significant mileage, fuel economy over the other. And they're all like, except for this one, like these are the ones that are swinging that variable. So 40, 34, 34, 48, which are all way over average. They're all 5-seaters. And what's the other variable we, curb weight? They're light. Yeah, they're light. Yeah, this guy, if you took this one out, you probably might even get a better result for hybrid because this one's pretty low, pretty heavy, and it's an 8-seater. So this is probably influential variable for hybrids. And it's likely that, if you took that one out, but I guess for a truck, um, that's pretty good MPG. Yeah, I don't know. Okay. Okay, then we're just going to plug in these variables I suggested and then get the expected MPG, right?
We deleted, it was like two variables we deleted.
Oh yeah. Well, I think I put it on the video, but if not, for this one, make sure it's just curb weight, seating capacity, and hybrid, because those are the ones that are left. Um, so why don't we define our model like we did with this? Oh, let me just do it from scratch. Okay, so we know that MPG equals an intercept of 42.47. Okay. Minus 0.01 times curb weight plus 0.98 times max seating capacity. And then the big one plus 9.84 times hybrid or not. Okay. 42.47 minus 0.01 curb weight plus 0.98 max seating capacity plus 9.84 hybrid. So our MPG with these metrics, or the MPG, would be 42.47 minus 0.01 times 5,000, okay, plus 0.98 times 5 seats, plus 0.984, oops, sorry, 9.84. Okay, and because this is not a hybrid, what do we multiply this by? 0. Okay, so MPG is the intercept minus the effect of curb weight times curb weight plus the effect of max seating capacity times seating capacity, and then because it is no hybrid, that's a 0, so that's going to drop out. So our MPG is just this part which would give us okay. Okay, 42. Do we get negative? Oh. Um, maybe.
Let me do that again.
What?
I said, let me do it again because I forgot to put a negative or subtraction somewhere where I should have. I added where I should have subtracted. That's what I'm
Okay.
saying. Yeah.
Yeah, we shouldn't get negative. Yeah. The curb weight should be negative. The seating capacity should be positive. Maybe I just put in too big of a curb weight. Uh, is there some other ones like that? This one's like 5006. No, I mean, the miles per gallon we're eating.
And we can use it in
Well, let's just say, I mean, just to make it come out to something, let's change curb weight to 2000. All right. So then, so MPG is 42.47 minus 0.01 times 2000 plus 0.98 times 5 plus 0. Okay, now 27.37. That sounds right. So maybe I just chose too big of a curve weight for the data set. I don't know. That was weird. So
And I see where my mistake was. I didn't
yeah.
do the ending. Like I didn't multiply that 9.84 times 0.
Oh yeah, that'll do it. Question? Did I mess it up? Yeah, no, I don't get it, but I can see what you. Oh, well, that's. I threw it out because we don't have that variable. Yeah.
I think you go back. For that.
Yeah, it's just, well, I didn't really look at what the, standard numbers were. So you should get something from like 15 to 40. You shouldn't get negative because obviously no vehicle has negative fuel economy, or it wouldn't make any sense. But okay, so if you have a curb weight of 2,000, 5 seats, and you're not a hybrid, then this is what you could expect your fuel economy on the highway to be, right? Okay. I know. Yeah. Yeah. Well, we don't have all the variables in there, but anyway. Okay, so that's a rough estimate of what we could expect. But if you get something weird, then don't assume it's like if I put in 5,000 and you said your miles per gallon would be negative whatever it was, no one's gonna believe you. So make sure it's within the context. Okay. All right. So I think we finished. No, have we? Is that what it? Really?
There's a typo.
That was D, right? Oh, that's what I did wrong. Okay. Yeah, so we've gone through, at least on video, last time or this time, part A, B, C, and D for number one, and part A, B, C, and D for number two. Okay. Now, number three isn't as time consuming because you don't have to reduce any of the variables because you're just looking at different plants and you don't really have to worry about correlation here because it's just total cost based on different plants being produced. And so they shouldn't really have a correlation with each other, even if it showed up, because this is just like product one, product two, and product three. And they should be kind of independent because they're separate products. So this one doesn't ask you to do the reducing. It does ask you for interpretation of the coefficients. So number three, I guess I'll wait for Christina to get back.
I was like, my. Like this. That guy
None of those are my names.
It's not his name.
Oh, man.
There you go. It sounds like, what was that? Sounds like Williams. Never mind, never mind.
Yeah. It's okay. I wasn't even paying attention. So you could add. Yeah.
What do we have to find that anything that over level 2,
Uh-huh,
you can find out if
yeah,
but the correlation,
correlation.
by looking at the second diagram, each other, that's the way the other,
Yeah, oh, it's hard to see up here
no,
in real life. I see.
the way they, even the one for 78 or 70, you didn't.
Yeah. It's probably the reason why I think the other part's easier is because you've done it a bunch of times. So if you, I have another example where you'll do some more correlations in a minute, and then I think it'll become more clear because I tried to write like a little step by step last time, which was look at the correlation matrix. Okay, and then any correlations that are greater than 0.9 in absolute value, there's a multicollinearity issue, and one of the variables needs to be removed, probably the one that's less significant. So that's right, that one goes out. And then you do it again, and then any correlations between 0.75 and 0.9. Well, that was step one. So so you start with seeing if anything's above it, right? Then step two, you look at if there's any correlations between 0.75 and 0.9, all right? And then it doesn't necessarily mean that you have to take them out, but you have to look at the scatter plot and look if there's a huge correlation. And if there is, you can make, and some of this is like a judgment call, right? You don't have to do any of this stuff. This one you should definitely take out. If your correlation is over 0.9, then they're too highly correlated. But usually when you get to like the 0.75, 0.8 range, you can also be mixing up the interpretations. So this step, I'd recommend just evaluating, but you don't have, I mean, you're welcome to say like, my correlation is 0.75. I left the variable in because I think it's important, or something like that. So you can convince me. But if it looks like there's a strong correlation, then if you want to have an accurate interpretation of the variables, it's recommended that you remove one of them because otherwise the results are getting intertwined with the two. But on the surface, just make sure anything over 0.9 has to be taken out because that's like you don't know which variables. Yes. Okay, so number 3 is the final one here. So we won't do the whole thing, but I'll do what you need to know. So why don't we run a regression with total cost as the dependent variable, and then units produced, plant 2 and plant 3 as independent variables. And note here that there's an indicator for plant 2 and plant 3. In plant 1 is the case when both plant 2 and plant 3 are 0. So what I mean by that is if you look at cost regression 3, here it is. Here's cost regression 3. So notice how this is structured a little bit different. So I define these to indicate, but basically we have a factory that produces at different months 1 to 16. There's 3 different plants, like 3 different locations for the plants, and there's units being produced at different plants. So the goal here is to determine if what's the effect on total costs of producing a unit, and then does that does total cost change at different plants? So is total cost a little bit higher, plant 2 or plant 3 or plant 1? And to do that, you have to model it like this, where this observation is at plant 1. So that means that plant 2 and plant 3 are both 0, which defaults to plant 1, just like when it wasn't a hybrid, the other case was no hybrid. So in this case, if that's a 0 and that's a 0, we're at plant 1. But if we're at plant 2, then plant 2 is a 1. If we're at plant 3,
Get it,
yeah.
then one.
Okay, so this is our, so this is the data set here. And then this is the part where we have to model plant 2 and plant 3 and plant 1. So I'm going to run the model with these things because here's observation 1. It's month 1, we're at plant 1. Here's total cost, here's units produced. But because we're not located at plant 2 or plant 3, it's going to be 0. So I can't put plant 3 also because then we'd have 4 different specifications. So when you're doing binary variables, you have to include one less than the total number, just like we did. It's the same thing for with hybrid, except we only had 2. We had hybrid, no hybrid. Here we have plant 2, plant 3, and plant 1. So I could define these as this could be plant 1 and plant 2. This could be plant 1 and plant 3. Either way, there has to be a case that when both of these are 0, it's the other one, right? So if you look at this one, this is observation 2, month 1, plant 2, total costs. See, now we're at plant 2, not at plant 3. This one, we're at plant 3, so there's a 1 for plant 3. And then back to plant 1, they're both 0s, which means it defaults or automatically goes to plant 1. So when you interpret the plants, they're in comparison to the plant that was omitted.
So 0, 0 is plant 1. Then 1.
Yes,
And the 1, 1.
there's no one. There shouldn't be any 1-1s.
Then false 1, 0.
Well, it depends on which. So this one is 1, 0 here, but it's at plant 2. See?
Yeah.
And this one's at plant 1, plant 3. So the 1 should indicate it's at that. Yeah.
Right. So one again, like think of the and then the one again.
Yes, that's right. It looks, yeah, if you've never seen this, it's weird. I'm not, that's why we're doing it. Yeah. And then the same, let's say we wanted to have like, don't type this in. Let's say we want to have an indicator for like month. You'd have something like February, March, April, all the way to December. Okay, and then if it occurred at that month, that would be 1. Otherwise, it'd be 0. And then you leave out like January. And then if they're all 0, then it goes to January. So you have to indicate 1 less. Otherwise, the model can't accurately run. So that would be like a February observation.
These are binary regression.
This is yes.
Hence the ones.
Hence the ones and zeros, exactly.
That's typically with plant 1 and 2 because plant 1, plant 2, plant 1 is just numerical.
Yes.
Yeah, that's not a binary.
No, yeah. So this part is not going to go into the model. We're not going to go into the. Yeah. But if someone gave you a data set that showed like it was at this plant in this month, you'd have to specify like this to run a model. If you put this, if you put this as a variable, Excel's not going to know what you did.
Yeah. The plant 1 is just indicating which plant. It's just giving you
Yes.
plant.
Yeah. Right.
And it's like binary. It's like 0, 1. Yeah,
That's right. Yeah. That's it. Yeah.
they're both on.
Right. Mhm.
Yeah.
That's exactly right.
Bring up your system.
Yeah.
Just look at they're both on.
That's right. That's exactly how you can look at it. These are off. It must be plant 1. Right? There's nothing else it could be. It has to be
So
1.
the next one was off, one was on, and one was off. That was
Yes.
You know, there's 2 under that.
Yeah.
That's just the table that's showing you which plant. It give you the answer. The other one's just that plant.
Right, because if you were to put this in the model, it would model it as like a number variable. And it might, it just won't come up significant. I mean, it's not gonna tell you anything. I don't know what it'll tell you, but it'll tell you that something that doesn't mean anything. Just, okay, so now that we've got that part, maybe we can um, run the model with total cost as the dependent variable, and then units produced, plant 2 and plant 3 as x variables, and then don't include plant 1 because when plant 2 and plant 3 are 0, that has to be plant 1. Okay, and we don't need to reduce anything, but we do need to run the model. Let's see. Which one is my actual? Oh, this was just the assignment.
Oh, yeah, that's the.
Okay. So why don't we close that?
So when you're running the model, it's just from total cost from C to F.
I think that, yeah, that sounds right.
Oh, so you got. Oh, look, that is.
Plant is not the Y.
Oh.
Yeah. Total cost, yeah, total cost is the Y. Yeah. Total cost is the Y. Units produced, plant 2 and plant 3 are the X's. Okay. Why don't we go back to the spreadsheet and you can just do data analysis, regression. Okay. Y range is total cost, so C1 to C49. And then X range is D1 to E49. And then labels should be checked.
You said E.
I did, yeah, sorry. Y range is C1 to C49, and X range is D1 to F49, right? Okay, then you can hit OK button. Make it a little bit bigger. Do a little formatting. Got it? All right, see? Home tab, format. This is just optional. Format cells, number, 2 decimals, comma sign. And I like to look at the full column, so you can do format autofit column width. And here we go. So you should,
The format cell, do that?
so if you click on this up here, which chooses everything, then under home tab,
Okay.
format cells.
Oh, we got it, I got it.
Yeah.
And then number, correct?
No, yeah, that's right. Okay, so this is what you want to put. Oh, good. Okay, then you can copy and paste this little chart. Control C if you would like, and paste it in the homework. Home, paste as a picture, just like we did before. And there's your screen cap of the results. Okay. Yeah, and I think I already defined these on the other documents.
Yeah,
He's got it.
no, it's cool. Cool. I'm learning all the mathy stuff.
Yeah. I didn't. I, I didn't hear that, but
No, it's a.
huh? Oh, it is? Yes. Okay, so then let's define our variables and interpret them, and then we're almost done with this part. Okay, so we need to define y equals y is total cost, or let's say total cost of business in dollars. X1 is units produced. So this is just, number of units produced. X2 now is plant 2. So so 1 if we're at plant 2. And then X3 is plant 3 location. So 1 if we're at plant 3. And we don't need to define plant 1 because if that's a 0 and that's a 0, then we go to plant 1. Okay, now why don't we define these guys? Where's my- Okay, units produced should be the ones that are a little bit difficult with these ones. So units produced is, and again, look at this, the R squared is like 0.99. So this is obviously like fake data because you really get a business that you can predict it 99% wise, but it does have the right interpretations. So the 204, that's how much it costs to produce 1 unit on average. So it costs this business roughly $204.15 to produce 1 unit of this product. So maybe it's like flat screen TVs or something. It's something that's kind of expensive, but you're hoping they sell it for more than the cost. and more than the cost of producing at the plants. Now, the tricky ones are the other ones because they're in comparison to plant. Oh yeah, yeah, one. Cost is business. Yes, thank you. Okay. Any ideas what the 12,971.97 means? What increases? Uh, partially. Uh, it does increase total costs in a sense, yeah. Yes, but in comparison to plant one, right? Yeah, yeah, that's the trick. So basically, total cost is roughly $12,971.97 higher at plant two compared to plant one. Okay, so in this context, this might be thought of as like a fixed cost because maybe this plant maybe it has a bigger plant. Maybe the land cost is higher. Maybe they use more energy efficient material or something. But I would think of these as like the fixed cost where you're starting out where total cost is about $13,000 higher at plant two compared to plant one, and then this one's low. So again, this one is also compared to plant one. So the negative 15,000 would be what?
Oh, so the total cost is roughly $45.29.
Well, this is plant three. So compared to plant one. Yeah, right. Yeah. So total again, yeah, right. Total cost is roughly 15,045.29 low at plant three, and again compared to plant one, which was a mid. Okay, oops. So if you had to rank them in terms of fixed cost or comparison, plant three would be the cheapest, plant one would be in the middle, and plant two would be the most expensive. So that's the trick, is any binary variable you're comparing to what was left out. So like if you did a monthly thing and you had a variable for February and you left out January, it's this much different compared to January because that was left out. And just like it was simpler for this one because everybody got that this was a hybrid. Makes sense. So, but it's the same concept. It's this hybrid gets this much miles per gallon compared to the one that's not a hybrid. In that case, it's easy because there's just one left out, but you can leave out as many as you want. You can do, I mean, I've seen models, or I've done models where you have like one for each state, and it's basically like you leave out like what's the first state in the alphabet, Alabama or something like that. Is it? Yeah. So all the variables are in comparison to Alabama. So you're just comparing everything to what was left out of the model. You have 49 variables, and the 50th one is the one that was left out. Or is it? Okay, okay, now all we're going to do next is let's make up some values and predict our total cost. So total cost equals the intercept plus the coefficient for units produced, which is 204.15 times units produced, plus the coefficient for 12,971.97 times plant 2, and then minus 15,045.29 times plant 3. Oh yeah, so yeah, that's probably yeah.
Basically. Yeah. We're defining.
Yeah, that's probably so you could if to be consistent with that, you can say like in this bracket 1 if at plant 1. Yep, yep. And then 1 if at plant 3. Right? So that way you know if it's not at those plants, it's a 0. Right? Okay. Now, why don't we predict the total cost where units produced is how about what are these things looking at? How about 100,000? Okay, and then all we have to do now is say what plant we're at. So what plant do we want to be at? 2? Yeah. Okay. So then our total cost would be equal to, predicted to be equal to 22,000 851.94 plus 204.15 times at that 100,000 plus 12,971.97, and then this is a 1 because we're at plant 2, and I'll just put this in there even though it's going to be 0, but it's going to be 15,045.29 times 0. Okay, and then it's just if you calculate this part, you should get the estimated total cost for this particular observation.
Quick question. Where
Yeah.
the 100,000, was that just the average of total costs you just, or is that just a number you just
I
decided to
just made
plug
it up just to have something to plug in.
in? Okay.
Yeah, so you can plug in any number you want actually.
Mm-hmm.
But I just made up 100,000 because I looked at the data set and it was, some of these numbers are like 190,000, 50,000, something like that. So I just picked something to put in.
I see. Okay.
But good question. 22. We got 204. Oh, wait, 53. Is that right? Yeah, 20 million, 450, 823. Yeah. Okay. Is that what you got? I could have done that one too. I'll double check. Oh, wait. 204.
That's exactly what I got.
Yeah, okay, that's okay, great. So our predicted total cost would be a little over 20,000. 20 million, sorry,
Yeah, it's 20 mil.
20 mil. Um, yeah, yeah, that's, uh, and that looks about, oh, that's what, I guess I plugged in a pretty high units produced. I looked at the wrong call, but anyway, it should be fine. So this, 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 there's a new manager and they're predicting higher sales. Yeah, yeah, yeah. If you've heard of the Bernie 4 week, that's not happening here. 4 day week, not happening.
I think I'm gonna see about trying this with an average total cost, adding them
Yep.
all together, just to
Yeah, that'll
because
probably give you something more usable. This, yeah, it's just if you're predicting too far out of sample, you might get some pushback because like if I were to predict it or just to look at these, you don't have to do this part, but if I'm looking at the graph between total costs and units produced, yeah, but see how it's the other way around, but this is total cost and this is units produced. So there's nothing on this graph bigger than 900. So if I'm saying that this model holds out of the sample, that's a big assumption because things could change. Like, if they triple production, there could be a strike, there could be more taxes, there could be they have to build another plant. So you don't want to predict too far to sample like I just did. So be wary of using the same model to make predictions that go out of the sample. So in theory, you probably want to stick with something that's within 900 range because that's what you've seen be predicted. Whereas predicting 100,000 has never been done at this point. Not saying they can't do it, but it's likely that something would change. Yeah. Yep. Yeah. So it's a good time because we're done with the homework, right? Yeah. It's okay. I don't. Uh-huh. Mhm. No, we're trying to see which plant, how the costs vary to different plants. So if it was more costly to produce at one plant versus the other. Yeah, so we determined plant 3 was the cheapest, right?
in order to do that, we need both.
Yeah. Okay. Yeah. Okay. Yeah. That.
It's not gonna.
No, not unless the data point is right on the line, but it's unlikely, or it's possible. Yeah, this one's fine, but it is, yeah, just because I did it by accident, it's a good lesson that you shouldn't try to predict too far out of sample. So I don't know if they can achieve this production level because they've never done it before, but you know, maybe they got a new CEO and they're like, you know, we're 10 timesing our production. I don't know.
How do you get the first variable? And then, you know, who gets or you figure it out?
Well, good question because so the data set would have come out like this. You would have only had, let's see. So you would have only had these variables. Like if you got this data set, it would probably have different months, different plants, different total costs that you just produced. You have to define plant 2 and plant 3 before you can do the model. Otherwise, it won't recognize the proper definition. Mhm. So you can write an if statement to do that for you, or you can just sort it and put in ones. It's up to you. But here, so basically you would do like, can't think of the specific function I would use, but I've done this. Well, we have a break, I'll tell you. I don't know. I know I've done this before as a setup, but I can't. I won't spend too much time on this. Oh, so here's one where I haven't done the whole thing yet. So you'd basically have to do like plant 2, plant 3, okay, and then this would say something like equals value ifs or just if. So if 2, comma 1, comma 0. Yeah, okay, that's what you do. So yeah, I actually should show you this just for future reference. So if you want, you could, let's do it on the one we already did, just to, So if you go back to the data set, you don't have to do this for the homework, but it's just a nice thing to know that it's noble ask because it's, so let's say that you wanted to define these columns yourself, okay? So what you can do is, let's say this is plant 2, and this is plant 3, okay? And to do this without doing it manually, you could go in G2 and be equals if, there's an if function, if 2, um, comma 1, comma 0. So you're specifying if, yeah, yeah. There, there we go. Okay, great. Yeah. Okay, so see what I did? Equals if function. So if this plant is at plant 2, then we put in a 1. Otherwise, we put in a 0. Okay, and because it's at plant 1, it's not going to put in a 1. Okay, and then I could like apply this all the way down the column, and it's going to code the plants that are at plant 2 as 1s, and the ones that are not at plant 2s as 0s. And I could do the same thing for plant 3 equals if this equals 3, comma, put in a 1, otherwise put in a 0. Okay, and then because it's not at plant 3, it's a 0, but if I apply this down, it's going to tell me like, okay, here's plant 3, here's plant 3. Then, because Excel doesn't like it when the numbers are in this if format, you'd have to copy and paste just the values, like I did here, and then run the regression. But you can write a little if statement like that. So it's not as complicated as it looks. I just forgot how to do it. Yep. I don't know. Let's
Manually after reading that, you actually don't like it, so you manually and feedback.
well, let's see. Let me try it again. I've had issues with it before, but I don't know. Excel does it like yells at you sometimes. Yeah. So let's say I only do it with those two. Oh, it worked. Okay, it does work. So maybe, yeah, maybe Excel's been learned to figure it out, but no, because I didn't put in the other variable.
Oh, yeah.
I just didn't want to mess with it. I just wanted to test. So without without the units produced, this is what it is. But look how much the R squared went down. Okay. So that was a good question. And I hope that wasn't too confusing, but you should be able to replicate this. And I'm recording this, so if it's, oh yeah, yeah, right there. Oh yeah, if you do like, yeah, so, and then you can do, well, we won't do too many things with that, but you can do like, I don't really use the if function, but I use the sum if function quite a bit because it'll sum things if you hit a certain category. But like this was I didn't know this function years ago. And so when I was like 25 or something, I was doing a big model where I had like uh, all the states and like 100 years of data, and I was trying to put in binary variables if there was like a new stadium built. And I basically did it manually. So I just typed in ones and zeros for like hours and hours, not knowing you could do this. Well, I didn't know it back then. Okay, so I think that concludes this homework. Um,
And so the class that I missed, the other part, the first half, has to be correct?
yes, yeah, yeah,
I'll do that.
yeah. So you should have everything there.
Yeah.
We pretty much did the whole homework. So, and this isn't due till next Saturday. Anyways. Okay, so any questions on this?
I do have a question. So in terms of your dissertation, are these methods we're going to do like a mixed method?
Yeah, I mean, you mean just doing a regression or doing?
No, just like would you use these methods like running models to analyze the data? You can still do that, right?
Yeah,
Okay.
yeah, for sure. I mean, yeah, especially doing the bind. Yeah, you're definitely gonna have something where it's a category. Like, is it most likely it's a location thing, or a year? Like, is it at this county, or is it at this year? So you're gonna have to put in ones for that. There are you can tell not Excel, but you can tell other programs to do that for you. Like you could just say, make me a state variable range, and it'll make all the dummy variables for you. But yeah, you're definitely going to need to use this concept. Yeah. And like it, even though it's a simple concept, it's if you're looking at like I do a lot of like predicting domain response load impacts, which is like looking at if the customers on this certain program reduce their electricity load during peak hours. And to do that, you basically have to say like these customers are on the program and these are not. And if the ones that are on the program reduce it, then you see a difference. So it's basically doing this. It's just much more complicated because you got to match it. But yeah. Okay, that brings us to the end of week 6. And oh, it's already 2:45. Yeah. Okay. Well, so do we need a break or do we already take breaks? Yeah, but I'm not supposed to do that. We can. I'm welcome. I mean, I'm not supposed to like, keep you captive.
No, he's saying to balance it out, but it's.
Oh, let's out early. Oh, I see what you're saying. I thought you were asking me to go over again. I was like, what are you? No, I meant that we hadn't. Well, maybe we will. So let's. This is I had a little exercise that wasn't part of the homework. So we can do. What time is this class normally over? 3. We're done at 3?
The class is from 1 to 3, so the block is 2 hours.
That was 3:30.
3:30?
3:25 or something.
Okay. Well,
I don't think it's.
yeah.
Oh yeah, 3:25.
Oh, okay.
Okay. No, we're supposed to have 3:25. 3:25.
No, but you say, why do they do that? Why do they make the class 3:25?
I have no idea. I don't know. Yeah.
Whatever.
They should start it at 1:05. because that's what I usually do. Okay, so we don't have to, let me just pull this up and we can decide what we want to do.
We're gonna homework over.
No, if I did give you homework, it wouldn't be due till after you came back. So I don't want you don't have to do work over the break, but nothing will be due like when you come back.
Yeah. Well, no. What I'm trying to say is like.
Yeah. Let's go. Where are you going in Hawaii? Okay. Okay, so under week 7, which is today, which we haven't got to yet, but that's okay, because that was the big thing, is finishing that homework. If you open up in-class exercise under week 7. So how about this? We can get out early. Um, if I run this, if I just run through the example, I'm not gonna do anything, just the question, and then you promise to work on it by next time, so we can talk about it. Okay? It's not a homework, but just so we can. So I made one more example here, and I wasn't gonna have you do it in class, but since it's already 2:47, it's getting close to not having enough time to do this one. Let me walk you through what I want you to do. So here is more multiple regression practice. In this one, you would use the dataset fitness, which is here. Fitness. Okay, and so we've got different things. We've got different people, different genders. The Y variable is defined in the assignment, but it's oxy, and this is like oxygen levels. And basically, you're trying to predict oxygen levels with different athlete participants by their age, weight, and these runtime, run pulse, rest pulse, max pulse. I don't know specifically how they translate, but they're like metrics. If you basically if you run a mile, they take your stats and they use those stats to predict your oxygen levels. So that's the point, is how do these stats translate into oxygen levels? So the exercise is use that data set. I said you could work in groups or individually. So even though you're going to do this at home and not do, but you can work together or not, up to you. Assignment won't be graded, but just for more practice, run a regression with oxy as the dependent variable and all of these variables as the x variables. So
Oxy would be what, right?
oxy would be, yeah. It's on the
I know.
yeah. So then gender, age, weight, runtime, run pulse, max, rest pulse, and max pulse are all the x variables. So there's 1, 2, 3, 4, 5, 6, 7. And basically in the data set, it should be all of these. And it's a bit out of order, but I'm sure you can figure out how to move it, where this is the y variable, and then these are the x variables, like the green ones. Okay, and then don't put this in, that's just the person's name. Okay, then what you're going to do is run the model, and you can reduce it by taking out variables that aren't significant, like we did last time. And then you can reduce it further by taking out the variables that have a high correlation. And again, for this part, you don't have to anything over 0.9 for sure take out. And then any other issues, you can kind of make a judgment call. But check for correlation. And then part D, I put this in, which I think you can do, but we haven't done it before, is part D. see if you can develop an Oxy predicted column in Excel and compare it to the actual Oxy values. So what you're going to do is make a column and write a simple formula that predicts Oxy would be on the fitted line, and then you're going to basically just autofill it. So for example, here's this is the actual, and you're going to make a column for predicted. And I put here, it's essentially doing this in Excel, where we've already typed out the formula, right? So basically in Excel, you're going to say like equals the intercept you got plus the coefficient times the age variable or whatever it is plus the coefficient times the runtime variable. And then it should, if you do this correctly, and if this makes sense, you should be able to do like, this is something like predicted Oxy. Okay, and you do something like equals some intercept, let's just say it's like 15, and then plus the coefficient for age, let's say it's like 0.05 times age, okay? And then let's say you have a coefficient for weight, and let's say it's like 20 times weight, and then this should give you the predicted line for each of these. And then you should get something that's similar to what the oxy is, but not the same. So basically, you're writing an equation to say what the variables would give you on the line, and then just compare it to the oxygen levels that you got from the data. So hopefully that doesn't seem too, yeah, but you can, you know, if you need help, you can ask your classmates, or Brian, you can text me.
No, I'm sorry.
That's okay. Um, okay, does that make sense? So you're gonna, and then once you get the equation you want, this is not the right one. Excel knows that, like, okay, I'm taking this variable and this variable, and then just do like an autofill, and that would predict based on the variables you're using what the predicted oxy would be. Well, this is not the right equation. I just made something up as an example. Okay, and then make sure when you're doing this part that only use the variables that are left in your reduced model. Otherwise, you won't have coefficients, right? And so in your spreadsheet, you should have you'll have another tab with the regression and some other tabs with all your, correlations, whatever. And then on the main tab, you can have a predicted variable, which is going to basically show that here was what oxy was, here's what my model predicted, and you can kind of see how close they were. Mhm. You do, yes. Oh, that's a good point because um, yeah, let's do that right now. Uh, yeah, yeah. So if I just go to if I just insert a column, and you're going to create a variable for either female or male. So let's say because Donna's first, we'll just make a female variable. Okay, and then you're going to say in your if statement equals if this equals f comma 1 comma 0. Oh yeah, sorry. Okay, so equals if b2 equals quotations f, it's a 1. If not, it's a 0. So then if you write that equation and double click the bottom right corner, it should code all the females as 1 and all the males as 0. You have to put in, because it's not a number, it's equals quotations F. Yeah, but see, like when you're going through, like it tells you what the argument is. So it says like logical test, if this is that, value of true is 1 and value of not true is 0. Oh yeah, good, yeah, good. If B2 equals quotations F, comma 1, comma 0. Yes. Yeah. Okay, and then good. That was a good question because I forgot that we had to do that. Because the data's the when I've done this before, it's in a different program and it does it for you. So it's yeah. So good catch there. So now basically like these are your x variables and this is your y variable. Yeah, and then it's probably easier to put the oxy variable on the left. You know what I mean? Like if I click on the C column and hit the insert button, and then I put oxy over there, Control X, Control V, and then delete this. So now, and then Excel's pretty smart even if you move things around. It knows that you're still calling from this. Even though this column is now here, it still keeps the same thing. So you should be able to run a model with this as Y, and then all these as X together. And then again, this formula is not correct. I just made an example. So you're going to put in this part, and then when you get the coefficients, just say like equals intercept times whatever variable, and it should give you something like, double check when you're predicting. It's probably not going to give you exactly, but if you get like 5 million or like -10, then it's probably wrong. So it should be somewhere in the range of 30 to 60-ish. Um, okay, and so that I think that's it. Try running the model. Try eliminating variables that are not significant, and then try eliminating variables that are correlated because of multicollinearity. And then this part, see if you can write the little oxy predicted column, and then we'll look at it next week. And if you can't do this part, no big deal. We'll figure it out next week. But I think some of you can figure it out.
The equation, where do you put that into? Like, where do you put that equation on Excel? Change.
Oh yeah. So if you have a column here called, you have to define your column as
Yeah.
okay. Then here in starting in D2, the function is equals
Okay.
if, yeah, right there.
It's not makes sense.
Oh, please. Oh, yeah, Rashid, you have a question? Or no anymore? Oh, low. Anyway, I see your hand raised, but I can't tell. Mhm. Yeah, and this one, I didn't make you define your variables, so you don't have to worry. The only reason I didn't do that is because I didn't know what all these things were. Like, I don't know what run pulse is specifically. Like, is that, you know, I know, but is it like revolutions per minute? I don't, you know what I mean? Beats per minute? Okay. All right. So try doing this exercise, and we'll talk about it next time. Um, and then if you get stuck, you can contact me or contact your classmates, or um, you know work together if you need to. Um, compare. Yeah. So homework 3 is due next week. So email that to me when you're done with that, and try to work through this example, and we'll go over this next week. And then I'll try to. I'm not going to give you homework over the break, but I'll try to do something next week, which will kind of either we'll start working with um, our studio, or I'll give you like a rundown of um, forecasting or something. But we'll figure something out. But I won't give you work over the break, but we'll see. Okay, I guess we can end at 3 today. That's since I did go over so much last time, and we don't have time to do this whole exercise together. So I'll go ahead and end it here unless you have any more questions. No? Yeah, okay. Any questions from Jordan, Michael, Rashid, Shamsa? Yeah.
Thank you very much, sir.
Yep. Okay, I'm gonna go ahead and stop the recording, but you can find this on the YouTube playlist probably tomorrow.